Hey, 8th grade. Welcome to another wonderful water quality lesson we have today, hosted by yours truly, Miss Jacobs. So let's go ahead and jump and get right to work today. So today, what I'm going to review with you is a couple things that Miss Mathis was talking with you about earlier this week. And we are going to learn 3 new water quality indicators today: nitrates, pH, and bioindicators. So today our objective, I will be able to use water quality indicators to assess the health or cleanliness of a body of water in order to determine if it's potable, safe, or contaminated for my use. Are you ready? Let's do this. All right, so first let's start off with our review. What in the world did we learn earlier this week? What day is it? No, I'm just teasing here. So the first thing I wanted to review with you all is the 3 different terms that we use when describing water's cleanliness. The first one is potable. Some people say potable, data, whatever you want, but for this lesson, I'm going to say potable. If the water is potable, that means it is safe for you to drink. Bottled water we know is potable. It's meant for you to drink. Anything that comes out of your tap has been regulated by the government. It is safe for you to drink. Then we have what's called safe water. You would think that's safe for you to drink, but not necessarily. Safe water is considered just good enough for you to swim in, but not necessarily drink. So if you look at this picture here of this lake and these kids having a rockin' awesome good time here, well, that water's safe for them to swim in and be in. They're not going to get hurt or anything, but we wouldn't necessarily want to take a huge glass of that lake water, put a straw in it, and drink it. Like, it's not potable, but it's safe. And then we've got polluted water. Dun, dun, dun. Yes, that water is contaminated. You should not go near any water that is polluted. It may hurt you, and it could have harmed you or organisms that could be living in there. Hence the picture at the bottom of all of the trash and dead organisms. So, potable, safe, or polluted. Those are the 3 terms you need to know. All right, next slide here. Again, we are talking about what water quality indicators are. And if you remember from chemistry, we use that term indicators of chemical reaction. So this word indicator means clues. What clues do we have to assess water's cleanliness? If you look at these 2 pictures, there's some observable ones. I mean, I wouldn't want to drink the glass that's on the left. I mean, I can use my physical clues to look at that looks disgusting. And then the other one looks clean. I would drink the one in the right hand. So when we look at these water quality indicators, we're going to talk about some physical tests that we can do with observing and using our senses. And we also have chemical tests that we can do. So what are some clues we can do or use in order to assess and determine, is the water potable, safe, or contaminated? Let's move on. Ms. Mathis talked to you about temperature. Temperature, we're just looking at how hot or cold the water is, right? You put a thermometer in the water and you record its temperature. So we found out from Ms. Mathis that the colder the water is, the better quality the water actually is, because it can actually hold more dissolved gases, like dissolved oxygen. So we do want the water to be cooler. Things like shade and different degrees latitude will actually help the water be cooler as well. So when we look at the relationship to temperature and dissolved oxygen, she told us how the colder the water, the more dissolved oxygen. Dissolved oxygen, or DO, abbreviated if you're cool, stands for, like I said, dissolved oxygen, and we want more dissolved oxygen. That's what fish need to breathe in the water. They don't have lungs like you and I. They have to breathe dissolved gases that are in the water, and that's dissolved oxygen. So they want levels like 9 or 10, but as low as 4 or 5 they can tolerate. And so if you look at this graph, there's an inverse relationship between those 2. The warmer the water, the less the dissolved oxygen. The cooler the water, the more the dissolved oxygen. So we want, that's right, cold water. She also talked to you about turbidity. Turbidity, we're looking at the amount of suspended particles, or the amount of stuff, the particles, the sediment, debris, the amount of stuff that's dissolved into the water. So the clearer it is, the lower the turbidity. The foggier it is, the higher the turbidity. So we want water that has a low turbidity. We want that clear water, because we know that there is able to be more dissolved oxygen in there. So the higher the turbidity, the worse it is, the hotter the water is going to be. What happens is sun goes into that turbid water, and then just like a game of pinball, if you've ever played pinball, bing, 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 and you have the little flappers, and you try and keep the ball, roaming around in there. Well, that sunlight just goes into that turbid water and then plays a game of pinball, bing, 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 off all those particles, and that solar radiation just stays in there, makes the water hot. Hot water, low dissolved oxygen, bad for fish. All right, let's move on. 3 more water quality indicators that we're going to talk about today. I love this meme. Water. All right, sorry. So today we're going to talk about pH, bioindicators, and nitrates. And we're going to bring in this new word, eutrophication. So let's talk about pH. When we talk about pH, we're talking about the acidity of the water. It stands for like presence of hydrogen ions. Don't worry about all that. But we're looking at how the acidity, and it's on a scale of numbers 1 through 14. I got the scale pictured for you right at the bottom of the screen here. You'll notice in the middle, 7, that green color right there, that's considered neutral. Anything from 6.9 down all the way to 1, that's going to be an acid. The closer you are towards 1, the stronger of an acid it's going to be. If you're looking at anything from 7.1 all the way up to 14, we would consider that substance to be a base. The stronger it is the higher the number, okay? So the closer you are to 7, the more neutral it is. Just because something is acidic, by the way, doesn't mean it's bad, and because something is basic doesn't mean that it's good. The more extreme they are, the more they can be dangerous either way. All right, your drinking water, you want to be at a 7. The water that comes out of your faucet has to be a 7. And you want the water that's in your water bottles to be a 7 as well. You can start having some health problems, and the acids can start affecting your teeth and your stomach if it's anything but a 7. When we talk about surface fresh water, so lakes, rivers, streams, they can hug numbers close to 7. So anywhere from a 9, and screen, anywhere from a 9 to a 6. So they want to be close to 7. Doesn't need to be a perfect 7. Swamps, they're going to be a little bit more acidic. You've got a lot of decaying leaves in there, and all that decaying process is going to make the water a little bit more acidic. Salt water, just like the ocean, it's okay for salt water to be a little bit more basic. But anyways, they want to be close as possible to 7. 7 is good, neutral. So if a lake has a pH of 7.8, is it safe, potable, or contaminated? All right, so we wouldn't say it's safe because it's not a 7. Only a 7 is safe. I like that. 7 safe starts with an S. I'm sorry, it wouldn't be potable, but it is safe. I should probably rephrase it. Anyways, it's not potable, but it is safe. It's between that 6 to 9, and so we'd say it's safe water. It's definitely not contaminated. It's not out of that range between 6 to 9. All right, how do you find the pH? So we have what's called litmus paper, a litmus test. They look like these little pieces or strips of paper. And what you do is you dip them in the substance, or you touch it to the substance, and this litmus paper right here will change color. And they'll change the color of any of the numbers on our scale, our pH scale below. So let's do some together. Let's test the acidity of lemon juice. Lemon juice, try to be like the one in the picture. So what I can do, open this up, got my lemon juice, and I'm just touching the top of this because that should be plenty lemon juice. All right, let's put this back on the top. Bum, bum, bum. And as you can see, the litmus paper changed color. It turned to about an orangey color. And so if I was to look at that pH scale right below me, I would say that lemon juice has an acidity level of about maybe 4, maybe getting close to 3. So we would say lemon juice is an acid because it has a pH value less than 7. Let's look at another one. Let's look at water. So I got some tap water from my sink here, And when we dip in our pH paper, you can see that it is, I'm trying to get you on the screen here. It's a little light green, I guess you would say, light green. This pH paper is kind of old. So anyways, it's very close to a 7. Sorry, I'm trying to, the light here is hard for me to get a good indicator for you. If I put this behind here, some white. But you can see it's got that green in there. So that's what you want your tap water to be. Now let's look at a household cleaner. Got myself some Windex here. I bet y'all been doing a lot of cleaning lately. And I'm just gonna spray this on this pH paper. And you can see, I don't want this to go on my keyboard here, but you can see that it turned a blue color. So we would say that Windex is a base because it's got a pH value close to 10. So it is a base. Awesome. We were in school, I'd have you have fun looking at all sorts of pH values of the different materials around around the classroom. They're fun to see, like soda, ketchup, things like that. They actually have an acid, but you ingest them. So bleach it's a very, very strong base. So you'll be doing an activity with that later. All right, changes in pH. What can cause a change in pH? Well, pollution. If there's pollution in the water, you're going to change the pH, making it most likely a little bit more acidic and making it difficult for fish to live. So if the pH changes, you're going to have polluted water or contaminated water. Let's talk about bioindicators. If you look at these picture of these bugs right down below, they look gross. They're like creepy, crawly little insects, and we call those insects macroinvertebrates. Macro meaning they're large enough to see with your eyes. You don't need a microscope to see them. And invertebrates meaning they don't have a backbone. They don't have bone. They have like shells on them and stuff. So they have like an exoskeleton, but they look disgusting. But what's awesome about these macroinvertebrates is that they are very sensitive to pollution. They're very sensitive. So if you see them in the water, it's actually a good sign. I know you probably wouldn't want to go swimming along with these bugs or these macroinvertebrates, but they are sensitive to pollution. And it tells you that if you see these, that the water is clean. Now, some of them are more sensitive than others. And as you can see in this picture, the ones that are more so this way are going to be your extremely sensitive macroinvertebrates. And the ones that are a little more this way are going to be, they can resist a little bit more pollution. So the ones that you see over here, you see those, man, water's looking good because these buggers right here, they cannot withstand like any pollution. So that water's got to be clean. All right. So how do I assess the water quality using bioindicators? And it's called doing a bioassessment. Well, if you see a bunch of them and you see a lot of them, then that's good. That means the water's clean. And if you don't see anything and you see just maybe one or two, or you don't see any living things in there, that's bad. So you want a high number of them, so a large population and a whole bunch of different kinds. So if you look at that picture right below me right here, things like that, good. The one below that, bad. So changes in bioindicators. If there's pollution, obviously since they're sensitive to pollution, they're going to die. And so changes in pH, temperature, dissolved oxygen, those are all coming from a polluted water system. Well, then if that happens, they die, they're sensitive to pollution, and it's a good indicator or a clue that the water's polluted. All right, last thing we're going to talk about today are nitrates. Nitrates are a chemical compound that contains nitrogen, surprise, surprise. There's also some oxygen in there. The molecule that's most commonly used with or associated with nitrates is NO3, sodium nitrate there. That is bad for humans. Nitrates are very, very poisonous for humans, can cause a lot of illnesses in babies and things like that. So it is not good for humans to have. We don't want any nitrates in our water. But because nitrates are a naturally occurring compound that does occur on the surface of the earth, they do make nitrates make its way, or their way, into water systems naturally. And so they can tolerate anything that's below 90 milligrams per liters, and it seems to have no effect on them. But again, we want none in our water. What causes them? And so one of the things that causes nitrates to occur the most in water is Fertilizer. We love fertilizer because we want our grass to be so green and we want our vegetables to grow. And, we love to, it also comes from animal waste, and we have to walk our dogs, and, who really wants to clean up their waste, and as it rains, every time you fertilize your yard or the farm or vegetable gardens, all those fertilizers run off into these streams and all that animal waste and so forth. Same thing with manure. Leaks in septic systems some older homes have, and it's this big tank that's buried in the bottom of their yard, and a lot of their the waste from their household goes into that, and they can leak and they can go into groundwater. So anyways, fertilizers are a main cause of these nitrates. We use them a lot. Human population numbers are rising, so we're starting to see a lot of fertilizers in water. And again, excess fertilizers is bad. Which takes me to our next point here. Have you ever seen a pond that's just covered with like a film of green at the top? Would you want to jump in there? No, you probably wouldn't, right? That looks gross. Right, it's not a good thing. If there's a whole bunch of algae, these algae blooms, which are just covered on the top of the water, that is a bad thing. And in science, we call that eutrophication, which is a big science word for algae bloom. And what happens is this eutrophication happens when too many nitrates get in the water. Excess is a bad thing. Too much get in the water, and it causes these algae blooms. And so what happens with these algae blooms is it makes, like I said, a blanket on the surface of the water. And when there's this blanket on the surface of the water, sunlight can't penetrate through. And so all the aquatic plants that are in the water, they start to die. And as they start to die and wilt, they make their way to the bottom of the water. And then what happens is the bacteria in the water, they're like, score, dead plants. And they just start eating and eating and eating and eating away at all that dead plants. Now, what's bad is that this bacteria, they're living, right? And they require that dissolved oxygen. So the bacteria populations start to get bigger and bigger in number, and they start taking all of that dissolved oxygen that's the fish need. So they start absorbing, they take that dissolved oxygen. And so the fish start to die. And so because of the lack of dissolved oxygen that's in the water. So no sunlight, dead plants, lots of bacteria. Bacteria steal all the dissolved oxygen. Fish die. Not a good thing. Eutrophication, bad. All right, so let's wrap this up here. We have been talking this week about 6 indicators that are used to assess the health of a body of water. 6 ways: pH, nitrates, bioindicators, turbidity, temperature, and dissolved oxygen. Those are 6 clues we look at to determine, is this body of water, is this lake, is this river healthy? Is it clean? Is it safe? Is it potable? Or is it contaminated? So you are going to complete a follow-up activity today that's going to use that information, and you're going to be given some data at the end to assess the health of a body of water. So sayonara, kids. Had fun. Love ya. Miss ya. Toodaloo.